Okay, let's have a look now at the T questions. We can have both T. Can we close this? Yeah, okay. And zoom out a little bit. Okay, right. 299. So the number of bacteria N in a culture after T days can be modeled by this function. To power 0, T divided by 4. Find the number of bacteria present after 15 days. Well, let's see what happens. To numeric. My inclination is to not round up, because what we're saying is that the next bacteria is in some sense 65% on the way to being formed. Be interesting to see what they do with the answer. Yeah, they round it up. I'd kind of be inclined not to round it up. I guess we're okay. We'll round it up then. Okay. Next now. 300. The demand in millions of barrels for oil in an oil-rich country is given by the function dP equals 150 times 2.7 power minus 0.25 times P, where P is the price in dollars. Find the amount of oil demanded to the nearest million barrels when the price is between 15 and 20. Why is it saying between 15 and 20? Should I go with like 1750? That's kind of weird. Whoops. Find the amount of oil demanded to the nearest million barrels. So 2 million barrels? What a weird question. I don't get about the 15 and 20 though. I really don't get I really don't get it. All right. 301. The amount A of a 100,000 investment paying continuously and compound for T years is given by the function AT 100,000 times exponential, I believe, 0.055 T. And then we want the amount after 5 years. Oh, the extra zeros in type. Okay. Now, let's see. Is that right? 301. 301. Approximately 131, 6, 5, 3. I have too many zeros, don't I? Oh, no. Okay, yep, there we go. That's right. Okay. 302. An investment is compounded monthly, quarterly, or yearly and is given by the function a, where a is the value of the investment time t, p is the initial principal, j is the amount. Okay. A, p, j, and t. P 1 plus j over n power nt. Pj as a multiplication. Pj and t. Okay. Given a yearly investment rate of 3.5% and a principal of 100,000, find the amount accumulated in 5 years. That's 3.5%. 5 years that is compounded daily, monthly, and quarterly. 5 years. Now, hang on. How does an investment compound monthly, quarterly are given, where A is the value of the investment at time t, P is the initial principal that was invested, J is the annual interest rate, N is the number of time the interest is compounded per year. Okay, so 5 years, but it'll be 5 times 60 months. I would have 12 months. I would have thought. And then compounded daily. 365. Does this work? Daily, monthly, quarterly, and yearly. Okay, so we're, but wow, what unit is the T in? I feel like I think that's okay. The next one then is monthly. Quarterly and yearly. I think that's right. I think that's right. They all should be kind of similar. Yeah. Okay. 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 These are a little bit tough. Okay. Three. I just wish T should be units should be specified as years. I think it is, regardless of how you compound it. 303. The concentration of hydrogen ions in a substance donated by concentration H plus measured in moles per liters. The pH of a substance defined by the log function. This function is used to measure the acidity of a substance. The pH of water is 7. A substance would be as acid. Find the pH of the following substances. What's the normal base here? Okay, so that's not base 10. So I'll have to fix that. Okay, so pH of H is defined as minus log H over log 10 because I need to change the base for this to work. So I'm not sure how to get a base 10 right now. Okay, determine the pH level of the bottom so it's round answer to 1 digit. I don't know why that A is separate. It shouldn't be. Okay. So pH of 1.6 times 10 to the power of minus 8. Okay. 3.16 and 7.94. Ah, can't do it all at one go, huh? Okay. Okay. Don't know why it prints it backwards, but anyways, so it's 4.1, 2.5, and 7.8. Let's see if that's right. 3. Oh, 3. 8, 3, and 4. I know it's. Oh, it didn't say one decimal place, did it? To one digit. That's a bit sneaky. 8, 3, and 4. Is that it? Oh man. Got caught out by the rounding again. 8, 3, and 4. Yeah. Okay. Tree of 4. See the sound still good? Yeah. Okay. Iodine of radioactive decays according to this function Qt, defined as Q0. So we'll measure it in percent. 0.08664 times T. Determine how long it takes to the nearest day for 95% of a quantity to decay. So left with 5%, I would have thought. Solve percent it's funny you put the percent in here. Oh yeah, because it's E. Percent of 2. Now, what's the unit here? Days, okay. Why aren't you solving for me? Strange. Qt. What's going on here? So weird. So weird. Let's try again. Percent E power. Let's try. Solve that equal to 5 for T. Why does it keep doing this? One moment. What's confusing me is I don't know why I can't get this working in Maxima. So, so I'm just going to try derive. So QT, well, the case doesn't actually matter, equals 100 times x minus 0.08664 t. Qt equals 5. Solve expression numerically. So about 35 days. Oh, does this not have an answer? Oh, because it's even. So that's the only thing that I have to be careful about. 95% of it to decay. I assume that means only 5% of it is left. So about a month. Okay. Yeah, I think I'm going to leave it there. This is getting a little bit messy. So there might have been some mistakes I made today. If you spot any mistakes, please do let me know. As always, thanks for watching, and I'll see you next time.